Did you ever sit in a lecture where the speaker is saying something but you really can't understand what he's saying? This video is a part of the study on architectural acoustics in classrooms. Architects and designers have to deal with acoustical considerations for a range of structures in their designs. They need to know what the Indian National Building Code or the NBC has to say about it, and what should be the ideal approach on how to design schools or how to design educational buildings. I am Amod from Consonance Acoustics. We are a company dealing in all acoustical requirements ranging from home theaters to industrial buildings and of course educational buildings. Don't forget to subscribe so that you don't miss our future videos. In this video, let's talk about the acoustics of a classroom, or broadly speaking, the acoustics of an educational building. I am going to talk about a bottom-up design approach where you will design the smaller blocks first and later combine them to create the entire plan. Let's get right to it. Architectural acoustics has to deal with two problems in the case of educational buildings: the indoor and outdoor noise and the speech clarity. I remember when I was in school, some groups would practice marching with the drums while classes were in session. That would cause a lot of disturbance. The classrooms of any educational institution should be equipped to deal with such outdoor noise. The new age classrooms also have AV teaching equipment, which can also disturb adjacent classrooms. And of course, students are arguably the biggest noise source in any educational institution. I am sure many teachers will agree. Although the Indian National Building Code or the NBC talks about sound absorption as a means to reduce noise, sound absorption, especially at the lower frequencies, is also critical to improving speech clarity in any space. We have a video made about that. Link for it is in the description. Don't forget to check it out after this video. NBC has a table for the reverberation time at 500 Hz octave band that has to be complied with. Let me explain this table to you. Look at the column on the right side. This is the data that you can actually measure because you cannot measure the reverberation time of a classroom full of students. The measurement gets very loud and can harm the ears of people inside the classroom. While measuring the RT, you need to measure the RT for each octave band from 125 Hz to 8000 Hz. The measurements will look like this. To comply with the NBC, the measured RT at 500 Hz should be below the values on this right side column. It is equally important to ensure that the RT is low at the 125 Hz octave band to ensure good speech clarity. Having higher RT at 125 Hz will reduce the speech clarity. To reduce the RT, you need to plan to have sound absorbers in the classrooms. It is important to design adequate spaces in the classrooms to accommodate these absorbers. If the classroom is too cramped or the height is not sufficient, maintaining a low RT at these frequencies will prove to be difficult. Merely installing high NRC absorbers may not solve the problem. It often leads to an imbalance in the RT at different frequencies. You will have to look at the absorption coefficients of materials at different octave bands to ensure absorption at the lower frequencies and the higher frequencies. You can use our patented low frequency absorber to ensure that the low end of the spectrum is sufficiently absorbed. You need to have the same approach when designing other rooms such as the assembly hall or the staff rooms. Once you have designed these individual rooms, it is time to think about how to group them. From an acoustical perspective, it is important to categorize the rooms in terms of how much noise they produce. For example, the metal or carpentry workshops will produce a lot of noise. The same is the case with, say, dining rooms or gymnasiums. On the other hand, staff rooms and libraries will need a lot of peace and quiet. The NBC outlines 5 classes of categories for all rooms from class A to class E. As per the NBC, it is desirable that these classes of rooms should be grouped together as far as possible. This will reduce the passage of noise and will not induce extra load for the insulation on the partitions. The NBC also outlines the minimum sound insulation between rooms of the same class. For class A rooms, rooms that are noise producing, like workshops and gymnasiums, the sound insulation between two class A rooms should be 25 dB. For class C or class D rooms, the sound insulation requirement becomes 35 dB. For class B or E, it becomes 45 dB. The NBC also recommends that for partitions between different classes of rooms, the sound insulation should be 45 dB. Remember, the sound insulation is never to be confused with STC value of any material. We have a video that explains what STC is. The link for that is in the description. Don't forget to check that out. Let me say it again. Sound insulation is not STC. The STC value is not equal to the sound insulation by the partition. This is how you can achieve these different sound insulations. To achieve insulation greater than 45 dB, you need to have a 230 mm brick wall. To achieve insulation greater than 35 dB, you can use AAC blocks of thickness 200 mm or more. Lastly, to achieve insulation greater than 25 dB, you can have gypsum sandwich partitions with rock wool having a density of 48 kg per meter cube or more, or you can use aerocon partitions. Now lastly, you need to plan for students banging on the floors, well, because they're students and they will do that. NBC recommends that the impact sound pressure level of the floors should be less than 70 dB. To achieve that, the NBC also recommends a solution of having 6 mm cork or linoleum tiles on concrete floor that should have a surface density of 220 kg per meter square or more. And that's it. This covers the general aspects to consider in designing educational spaces. Of course, special cases arise as architecture is not as easy as it sounds. This is where people like us come in to help you. You can always reach out to me for consultation and information on our products. My contact details are mentioned in the description. Do subscribe as we are planning to add in more videos on such topics. Bye for now and see you next time.